The following video will be how to do mesh convergence on an irregular geometry using COMSOL's default mesh settings. So here we have a circle, and we're just going to use this as a basic example. We have thermal conductivity, density, specific heat. It starts off at an initial temperature 293, and it's being heated all around. So the physics isn't the point. The point is to do a mesh convergence using COMSOL's built-in mesh settings. So say the size. So that's a normal mesh. That's a coarse mesh. Here's a finer mesh. Okay. So if you notice, there's 5 different parameters for the mesh that we can do a sweep on all simultaneously. So what you'll do is you'll rename these 5 different variables. And so I'm going to use a list of the variable names maximum E, minimum E. Don't worry about the red. It just means we haven't defined these parameters yet. Grow R, res curve, and res nar. Okay? So what you're going to do then is go up to global definitions, add parameters. We're going to add this arbitrary variable name first. I'll explain that in a second. Max E. And on my list I already have the settings for extremely fine, normal, and coarser. And so I'm just going to type in the normal, 0.0134. So all the all the middle values. Min E, 6E, -5. Grow R, 1.3. Res curve 0.3 and res nar 1. Okay, so now if I go back to my mesh, there's no more red, and I can just click build all, and it gives me the normal mesh. Okay, so we want to do a sweep. So we want to do a mesh convergence, which is essentially a parametric sweep of the mesh. So you're going to go to your study, you're going to right click study 1 and add a parametric sweep. Okay. So you can type in these lists into these parameter names and type in the values. Or you can do something easier, which is type it into a text document and then just import it. So to do it in a text document, I'm just going to leave my list up here and do a little example down here. Let me make up a variable name called density. And I wanted to give it 3 values. I would do 1,000 space 2,000 space 3,000. So you have to do the parameter name, value name, value name, value name, and so on. Okay? So you can do as many as you want. You can do 5, 6, 7, 8, whatever. Okay. So once you have so what you need to do is record the different values for the different mesh settings. So if I had gone to see it changed the values. So I need to go to extremely coarse, build all, and write down these values and make a list. So go to normal, build all, make a list, extremely fine, build all, make a list. And so you have to take all these values and put into a column for each one based on how many you want to do. So let me go back and change these real quick. Min E, grow R, res curve. Oops. Capitalization matters. Res nar. And it's all correct because they're all black. Okay. So my parametric sweep, I have my text document with my extremely fine, normal, and coarser mesh. So that's 3 columns of values. And I'm just going to click this import. I'm going to go to desktop. And I'm going to go to parameters. And what I see is I see 3 values here, 3 values here, 3 values here, 3 values here. So, and it's going to do these specific combinations. If you click all combinations, it'll do all permutations of these values. So it's best just to do specific combinations. Okay? So I have my parameter sweep with the different meshes. So if I right click study all and compute, it's going to go through each 3 meshes. And while it's going through, I have this arbitrary here. That arbitrary value is not actually defined anywhere in the model. Why you have to do that is because COMSOL needs a monotonic parameter value. So I just chose arbitrary to go 1, 2, 3, and based on how many you have by 4, 5, 6, that way I don't have to worry about these values being monotonic. I already have one monotonic parameter into the top one. And it also gives me a good labeling system. Okay, so I'm done with the parametric sweep. I want to look at the results. So the easiest one to do would be a cut point 2D, and I'm just going to look at the center. So it's that point, the center. Add a 1D plot group. Add a point graph. I'm going to click plot. Oh, but that doesn't give me anything. So what you have to do, this is a little messed up, is go to your cut point 2D1, but your cut point 2D1 needs to point to your solution 2. That's your parametric sweep. And if I click plot, I see the temperature for all 3 meshes. And what you can obviously is you can guess that red one is the coarse mesh. And so if I go to show legend, you can see it's the 3rd one, which has the biggest element size. And so that's how you do a mesh convergence with the COMSOL built-in settings. You can't just type in normal, fine, etc. You have to write down all the values. Then you can just put them in a text document, import into a parametric sweep, and do it that way. So this concludes this video on how to do a mesh convergence on an irregular geometry.